So welcome everyone to STEM Talks 9, session 9 of the 7th Polygen Symposium of Rising Scholars. My name is Tyler Vitone and I will be moderating today's session. The goal of the symposium is to celebrate and showcase the hard work of Polygen scholars, all of whom have tirelessly worked on their projects over the past couple of months. We have 5 student presenters in this room, presenting on a variety of topics today. A fellow member of the Polygens team will also be scoring the presentations of the students in the session, which will help us to ultimately determine prize winners after the event. If you have any questions throughout the presentations, feel free to type them in the Q&A if you're an attendee. And at the end of a speaker talking, we'll have time to cover those questions. And so the 5 speakers in today's session are, and this will be the order in which they present: Atul, Venkatesh, Maisie, Wang, Jessica Zhao, Jessica Xu, Abhidi Brahnmath, and we will start with Atul.
Sorry about that. Just give me a second to get.
Don't worry, take your time.
Is everyone able to see my screen properly?
Looks good.
Awesome. Sorry about that. Okay. Hi, everyone. My name is Atul, and my Polygens project is titled Sleep's Effect on Synaptic Plasticity, a review of competing hypotheses with an introduction to the affective salience model. So what is synaptic plasticity and how does it relate to sleep? So synapses, which are the connection between 2 neurons, aren't static structures, but rather malleable based on its usability. And that is basically what synaptic plasticity means. And it is theorized that synaptic plasticity occurs during sleep. So this changing of synapses happens during sleep. But exactly how synapses change during sleep is still unclear, and there are many hypotheses to explain it. So this slideshow will go through those hypotheses and evaluate them. The first of such hypotheses is the synaptic homeostasis hypothesis, or SHI for short. So quick introduction to SHI. SHI states that there is a universal downscaling of synapses during sleep. Now, why might this happen? Well, during the day, as an individual interacts with its surroundings, it makes millions of synapses. Every sensation, every perception, all of those result in synapses firing. This multitude of synapses take up a lot of mind space, which takes a mental toll on the individual that causes more stress. It is theorized that during sleep, these synapses are downscaled, shortened, and made more efficient to prepare the brain for a new day. And there is evidence for and against SHI. I'll first go through the evidence for SHI. First, there is a study done where AMPA receptor phosphorylation levels in adult mice increased during wake and decreased during sleep. This is evidence that there was less synaptic activity during sleep than there was during wake. Second, another study done showed that MESPC frequency and amplitude in the frontal cortex of mice increased after wake, once again showing that there was a lot more synaptic activity during wake than there was during sleep. Lastly, in juvenile mice, the ratio of dendritic spines were less in sleep than in wake, and because dendritic spines aid in the transfer of information between neurons, because there were less of them during sleep, it once again indicates that there was some form of downscaling that occurred. Now, there is also evidence against SHI. First is that it's proven that sleep leads to long-term potentiation and memory formation, which is a sign of synaptic strengthening. Because some synapses strengthen, this probably means that they aren't universally downscaled. So that's against the theory. And to back this up, it was found that protein synthesis that played a role in long-term potentiation, or LGP, increased during sleep. And the last part, which will also lead into the next hypothesis, is learning. which is that there was a study done where mice that learned something new before sleep were found to have new dendritic spines formed after sleep, which shows that there was some form of synapses being strengthened during sleep. Next is the boom and bust model. So a quick introduction to the boom and bust model. Essentially, during sleep, synapses first encounter a boom in activity before being universally downscaled, which is the bust. The initial boom could be a result of memory reactivation, which is where certain synapses are reactivated during sleep and strengthened, like moving from the short-term storage to the long-term storage. And this memory reactivation could be influenced by learning right before sleep, as we mentioned in the previous slide on shy. But even though there is a universal downscaling after the initial boom, there is still a net increase in synaptic activity from wake to sleep. And there's evidence for the boom and bust model. First is monocular deprivation, or MD, which is an experiment to measure synaptic activity where one eye is deprived. And this can be done in organisms, but it's mostly done in cats. And it was found that the synaptic activity increased during sleep in the non-deprived eye and stayed the same in the deprived eye, which indicates that there is a net increase of synaptic activity from during sleep, which then proves the boom and bust model. And also, a study on male Wistar rats found that after a period of learning, memory reactivation and consolidation increased during REM sleep, indicating that memory reactivation must play a role during sleep. And lastly, a study in plate cells of rats found that information acquired during wake was re-expressed during sleep, once again backing that memory reactivation. Now, I had a couple questions about the boom and bust model. First, is learning before sleep necessary in producing an increase in synaptic activity? What if there was no learning activity done right before sleep? In this case, would there be an initial boom if there was no clear learning activity done right before sleep? That was a question I wanted to answer. And second, do all synapses increase and decrease correspondingly? For example, like, does there have to be an initial boom followed by universal downscaling? Could those be switched? Does order necessarily matter? And lastly, is there anything else involved? Could there be any parts of the brain that are involved in synaptic plasticity that weren't already talked about? This last question led me to formulate my own hypothesis called the affective salience model, or AS for short. So what is AS? While the previous two theories focused on synaptic plasticity in the hippocampus region of the brain, the AS model focuses on the amygdala, which is the fear center of the brain. So basically, it's about how emotional circuits and amygdala activation during sleep can implicate synaptic plasticity. And the theory itself says that sleep has two purposes regarding emotionally charged synapses. First, sleep serves as an avenue to both downscale emotionally charged synapses, but also to strengthen synapses for long-term memory consolidation. There's also a homeostatic component to this, similar to shy, wherein sleep allows for synapses to be emotionally regulated to prepare the brain for another day. And this theory kind of explains why memories that have more emotional connection to us are more likely to be remembered, but also why like the emotionally charged images we see every day become more and more bearable the more and more time we are away from it. And there is evidence to support AS. First is that there's an existence of amygdala hippocampal networks. Because the hippocampus plays a role in long-term potentiation and synaptic plasticity, as proven in the previous two theories, because the amygdala is inherently intertwined with the hippocampus, the amygdala must also play a role. And to back this up, it was found that electrical stimulation of the basolateral amygdala, or BLA for short, evokes synaptic potentials in the dentate gyrus of the amygdala, which induces LTP, also proving that the amygdala and the hippocampus are inherently connected and that the amygdala plays a role in LTP. And to connect this to sleep, it was shown that electrophysical recordings and neuroimaging studies show amygdala activation during sleep, which, because amygdala and hippocampus are inherently interconnected, the amygdala also plays a role in inducing LTP, and the amygdala and the hippocampus are both activated during sleep, shows that the amygdala must play a clear role, thus supporting the theory. And the last part is the last part of the theory, which is surrounding emotional regulation. Basically, there was a study done of 150 people who were shown an emotionally charged image and then told to go to sleep. After they went to sleep and woke up, they were shown the same image again, but they found that the image had less emotional appeal. It was less emotionally stressful, which shows that sleep serves as an avenue to regulate the emotionally charged images and the emotionally charged connections which people make. Now, how can we further test this theory? First, we can have more electrophysiological recordings of synaptic activity during sleep. This can show us are synapses truly strengthened or weakened? When are they strengthened? When are they downscaled, etc. Second, we can look more at the amygdala and hippocampus during sleep and see like when is the amygdala activated? When is the hippocampus activated? Are they activated in unison, etc. And lastly, we can look at these recordings during different stages of sleep. Does amygdala and hippocampus activation happen more during REM sleep, during NREM sleep? All of this would give us more information that could better our hypothesis. So thank you so much for watching. Special thanks to Polygens, my mentor Kyla, and my parents for their support throughout this project.
Thank you, Atul. Great job. And so if you have any questions and you're an attendee, feel free to put it in the Q&A. I have a few questions of my own. I'm interested in, this is a little outside of my area of expertise. So I know you said like cats are a common model that are used in these kind of studies. And I'm wondering if you could shed a little light on like, what do those studies look like? How do they collect the data? What are they actually looking at in those kind of studies to collect information?
Sure. So I'm not really that experienced in it because this was, again, just a literature review, so I didn't have any firsthand experience, but I'm sure like the scientists would be able to get like electrophysiological recordings of the cat during different stages of sleep and see like whether synapses were firing, whether more dendritic spines were formed, et cetera, to see if like synaptic activity was increasing or decreasing in the cat.
Cool. Great. And if there's any other questions that come in, feel free to put them in and we'll have time at the end as well. Next up is going to be Maisie to present. Thank you so much, Atul.
Oh, can you see my screen?
Yes, all good.
Okay. Hi, everyone. Today, I will talk about the future of modeling and treating Alzheimer's. So did you know that Alzheimer's is the 5th most common death of America? And then, in fact, according to CDC, about 53.8% of the American population are diagnosed with Alzheimer's. There are two subtypes of, There are two subtypes of AD, FAD and SAD. FAD represents people who are 65 or below have been diagnosed with Alzheimer's, and SAD, on the other hand, represents people who are 65 or above diagnosed with Alzheimer's, which makes up the majority of the AD population. Because there are many factors that contribute to AD, it's difficult to initiate therapies that can cure Alzheimer's. Yet there are therapies that may lessen the symptoms and slow down the spread of the disease. So today we will mainly focus on gene therapy, but I would also like to talk a little bit about the drug therapy because drug therapy is essential in treating Alzheimer's today. So before we dive into today's main focus, I want to talk a little bit about the history of Alzheimer's disease. Alzheimer's disease was first discovered in 1906 and was not seriously studied until the 1980s. Then in the 1990s, clinical trials of drug treatments become popular until today, while gene therapy was only discovered in 1993. And from the 90s to today, there were like many trials and studies on drug therapy, while there are some ethical issues and concerns about gene therapy, so it hasn't started its first clinical trial on humans until last year. That being said, drug therapy is the most common and affordable treatment to treat AD today. Though it cannot cure the Alzheimer's, it can improve one's brain functionings and lessen symptoms such as memory loss and decrease in cognition. Most drugs are used to treat early to middle stages of Alzheimer's, with a few that treat late stages of Alzheimer's. So some commonly prescribed AD drugs include donepezil and NMDA. Donepezil are able to prevent the normal breakdown of acetylcholine, and NMDA is able to block the NMDA receptors, which play an important role in learning and memory, and also spatial memory. So finally, the last one is aducanumab, or Aduhelm, which is a drug that came out like in 2021 and is an FDA-approved Alzheimer's modifying agent that intends to break down the amyloid beta aggregates, which is a major factor that affects Alzheimer's into amino acids. However, it's very controversial whether aducanumab can actually break down the aggregates. And some studies even show that the drug may cause allergic reactions and amyloid-related imaging abnormalities, which is very dangerous. However, whether it's aducanumab, donepezil, or NMDA can only lessen the symptoms rather than curing AD. So gene therapy, on the other hand, is a future potential therapy that treats Alzheimer's through gene editing by using technologies like CRISPR-Cas9 and targets specific gene variation and or molecular components. One of the most important ones is ApoE, which is a well-known lipid carrier that influences the risk of AD, has 3 variants. So the first one is E2, which lowers the risk. E3 has no impact, and E4 increases the risk of AD. People may carry one or more allele variants of those 3, and several experiments have been done eliminating ApoE levels, switching the E4 variants out, but this may only apply to mice models. Mutations in genes like PSEN1 and 2 will affect APP protein based on the mice models, which then increases the beta secretase and furthermore increase amyloid beta aggregation, which I will show later of how this works. BDNF gene also plays a key role in Alzheimer's since it reduces neurodegeneration and memory loss. So it's important to target all of these molecular components. All right, so these are some figures that may help us understand the concepts that we talked about in the previous slide. So on the top right figure, it's showing the APP protein. So usually APP protein without mutations happening, it will go through the alpha secretase. But then if PSEN1 or 2, like these genetic variations, get mutated, then APP may go through the beta secretase instead, and then creating amyloid beta aggregates for me in the end. So Cas9's job is to fix these mutated genes so that APP won't go through too many of the beta secretase processes. The bottom left figure talks about ApoE. So in this case, the bad ApoE is the E4 variant, and the good one is the E2 variant. The reason that E4 is the bad ApoE because it cannot clear out the soluble amyloid beta, which as time goes on, these soluble amyloid betas will form into plaques and pile up in the synaptic region of the brain and will cause memory deficits. So it's also important for Cas9 to increase the E2 variant in specific regions of the brain. So Cas9 has 4 main delivery systems: the Cas9 sgRNA complex, adeno-associated viruses, lentroviral CRISPR-Cas9 system, and the adenoviral vectors. The Cas9 sgRNA complex system can minimize the effects of targeting the cell toxicity, but it's very challenging to deliver sgRNA to targeted regions when it comes to like a larger size cell. Another delivery system is AAV. AAV is a viral delivery system that uses viruses that carry the targeting genes to widely infect different tissues using its ability to move freely around the cell. And this type of delivery system is found to be useful to treat AD expressed for 1 to 2 years. Other than AAV, the LV system is also a viral delivery system that may treat Alzheimer's by targeting specifically the APP protein. The delivering RNA virus contains a genome that's able to reversely transcribe the DNA and furthermore maintain and stabilize long-term expression. And the LV delivery system is able to treat FAD patients specifically. And then the final one is ADV, which is originally a dangerous and incurable virus. But what scientists find is that they can transcribe their own genes rather than relying on the cell. So then that means that if we use this kind of treatment, that they can avoid mutations, which further can like transcribe their own RNA. So as I mentioned before, there are some ethical concerns with gene therapy. So gene therapy today mostly applies to creating Alzheimer's models rather than using in clinical trials. So it hasn't started its first clinical trials on human until 2021. That's now investigated by Professor Mark Tosinski of UC San Diego. In this phase 1 human trial, researchers are able to deliver a key protein into the brain of participants with AD or mild cognitive impairment in order to increase the BDNF genes, which is helpful for treating Alzheimer's. So even though this trial remains ongoing, the Tosinski group and many others have already done many experiments on mice models, and hopefully their clinical trials will follow this vein of success. After talking about all these therapies, we have come to our conclusion, which I make a comparison chart. So drug therapies have been approved and used since the year of 1993 to treat Alzheimer's. And since then, many researchers and experts and health organizations in the field have been investigating on new drug therapies. So just in between the year of 2002 to 2012, there are already 413 Alzheimer's trials have been completed. Even science fraud can't prevent it with drug therapy, but with gene therapy, though not matured, may be more effective on treating Alzheimer's than drug therapies in the long run. Additionally, gene therapy is a one-time treatment that's long-term effective, while drug therapies are short-term and will become less effective over time as people take more doses. This means that drug therapy can't be a long-term solution to treat Alzheimer's. And gene therapy, on the other hand, may solve a problem that bothers 5.8 million Americans today, according to CDC. This is the end of my presentation. I hope this is helpful, and thank you for listening.
Thank you, Maisie. Great job. Great. And again, if you have questions, if you're a panelist, feel free to ask questions. If you're an attendee, you can put it in the Q&A. One question I have that I'm just, it seems like we're at, a frontier. Do you have a sense of when those first results of the gene therapy trial will be published? Is it something like to expect soon, or does this typically take years to come? Do you have a sense of when we'll start to know the results?
I think it will probably take some, at least 1 to 2 years, or maybe 3, depending. Because this, again, gene therapy is not it's the first human trial, so it's not totally matured yet. But we have been doing many experiments on mice models, and on other animals too. So hopefully it will come out soon.
Awesome. Thank you. Exciting times we're living in. All right. Abhidi, go ahead.
Yeah, I first wanted to say such a cool presentation. I'm also pretty interested in neurodegenerative disorders, so it's pretty cool to learn more about Alzheimer's. I just wanted to ask, is there a gene therapy that scientists are working on for early onset dementia, which I think can lead to Alzheimer's? Is there like a difference as to how early onset Alzheimer's is treated versus like normal onset?
Oh, that's a good question. So I'm not sure, like in gene therapy specifically, if they have it, but based on the drug therapies, they do have like whether it's mild and then to severe stages. Because what happened is that in mild stages of Alzheimer's, you will have less. You will compare to severe stages, you will have less amyloid beta aggregates and like things like top proteins. So it's essential that we treat them differently, if that answers your question.
Yeah.
Yeah.
Right. All right, Jessica Zhao, you're up next. And I will pin you. Thanks again, Maisie.
Okay, can you see my screen?
Yes, all good.
Okay. Hello, everyone. Today I will be presenting on gentrification in Inglewood, California through the years of 2010 to 2020. So first, let's begin by introducing some background information that will be necessary to know for the presentation. Inglewood is a neighborhood in Los Angeles, California that has changed a lot since it has been established. Today, Inglewood is known as a city that is more than 40% people of color and is mainly dominated by Black residents, but the history of it is more complex. When first established, Inglewood was a white city. In fact, according to Inglewood's 1960 census, there were only 29 Black people living in the city. The city was redlined and was exposed by a series of riots. In 2016, the construction of the SoFi Stadium, which would be home to the LA Rams and San Diego Chargers, was announced to be built in Inglewood. So this stadium would surely change the community in many ways. I investigated one possible major change that the stadium brought to the community. It made Inglewood gentrified. Well, what is gentrification? Chances are you've heard this word before. It's basically a process of evolution for a neighborhood. As new, richer residents move into a certain neighborhood, old residents are pushed away. To measure whether Inglewood had been gentrified quantitatively, I needed a model to work with. So I adopted the McKenish et al. Model, which says that the median household income of the neighborhood needs to be in the bottom 20% of all neighborhoods nationwide, and that the average family income has to increase at least $10,000 in the last decade. I figure that this model does not fit my study, as California has higher average family income than most other states, so the definition I will be referencing is the same, but only relative to LA. And you can see the model in this slide. So previous studies have already addressed gentrification in neighborhoods and how that affects things like neighborhood change, development and inequalities, population health, and involuntary displacement. The two studies that I went through did work on Milwaukee, Wisconsin, and New York City. I realized that both studies struggled to find a consistent source for their data, and they both surveyed residents in the city for data. I also found that these two studies have contradictions in their main argument. The New York City study says that people of color's salary increased during gentrification, and gentrification is valued by disadvantaged households. Slater's study on Milwaukee shows class inequality because lower class is forced to move out. So this helps to put my study into the conversation. So how will my study differ and contribute to the other studies already done? Well, first, my study addresses the challenge of data collection. I take data from one constant place with trustworthy numbers for all demographics I use. Second, my study is done solely on Inglewood, California, through the years of 2010 to 2020. No other study has ever been conducted here before on gentrification, so my results will be unique. Using what I find, I will add on to the existing conversations with evidence. No one has ever used my definition of gentrification before either, so it will be interesting to see what the results bring. And here is my hypothesis for the project. So obviously my study depends on data. This is the only way that I would know if Inglewood was gentrified or not. My consistent source of data came from ACS, the American Community Survey. This is data accumulated from a questionnaire that I sent out to 295,000 addresses monthly from all over the country. Demographics, employment rate, and educational status are types of things being asked. There are many filters that can be chosen to narrow down the range of data. For example, on the first picture, the only filter I selected was Inglewood, California, and out came 3,138 results. After selecting a few more filters, such as the type of survey, year, and topic, results narrowed down much more, and this is how I got my data. So the methods of my project included 3 major sections. The first thing I had to do was to test if Inglewood was gentrified through the years of 2010 to 2020. I wanted to prove the 2 criteria that I had previously mentioned of my definition. I took data from tables I found on ACS about income that included both median household income and average family income, and organized the data using Google Sheets and ended up satisfying both criteria. The second thing I did was pick out a few significant demographic variables: percentage of people of color, median household income, employment rate, and median price of homes. I got this information for all 10 years from ACS. I then created bar charts and line graphs to visualize the data and see which variable had the most impact on gentrification. On the right is the code I wrote for making a bar graph after importing my data. I also performed several correlation tests and made scatter plots, furthering data on my graphs. I looked at if 2 variables were statistically significant using the p-value, which I also calculated with the code. So results, I found that Inglewood is gentrified. The graph for the average family income through the decade is shown. It is evident that it increased more than $10,000. That's the first criteria satisfied. The median household income also fell in the bottom 20% of the LA neighborhoods, and the graph on the left shows it in comparison with the percentage of people of color. That's the second criteria satisfied. The 2 bottom graphs show the 3 key demographic variables that had the most significant change throughout the decade. On the left, in 2016, when the stadium announcement was made, the median household income grew a lot. The graph on the right shows employment rate with median price of homes. When employment rate rises, so does median price of homes. And this is a drastic rise. Furthermore, I also performed correlation tests for all 6 variables I used and made scatter plots for the statistically significant ones. On the right is the list of statistically significant correlations. On the left is an example of a scatter plot with an obvious negative trend. The correlation tests I performed pointed out a few key variables that are likely to be correlated with the construction of the SoFi Stadium. The 2 variables that increased the most were the median household income and median price of homes. This is a key indicator that some changes occurred in Inglewood to make the pay rate rise. Evidently, with the announcement of the stadium construction, more employers would be hired as construction workers since less of the population worked in other fields. The pay rate for the other fields must have increased, increasing the overall pay rate of the community of Inglewood. Another change I noticed was that the percentage of colored people in Inglewood decreased. This shows some economic development in Inglewood, and my study replicates the idea that even middle-class people of color are increasingly unable to remain in a gentrifying neighborhood. In conclusion, my hypothesis I made at the beginning of my project was proved correct. In addition, the biggest takeaway from my project is that gentrification indeed does change the community of Inglewood and push older, less privileged residents away. Future research could build off of mine by investigating this same topic a few years later. Last but not least, I would like to acknowledge my mentor, Tara Marie, who helped me immensely with the ideas of my project. She read and edited my draft paper and taught me relevant information to my project. And that's my presentation. Thanks for listening.
Great job, Jessica. Let me just do that. I have a question about, with the insights that you gained, kind of what are the next steps of your work and what do you hope to, that this work will show or how this work will impact, the literature of what's known out there?
So I feel like the next steps would maybe someone could try to do something similar that I did on a different city maybe and see how the results will come out. I feel like the impact of my study is that gentrification is a real thing and it's going on, and I just proved it with my data.
Great. Again, if we have time at the end and you have other questions, feel free to put them in the Q&A. I'm curious how you chose Milwaukee and New York City as the two kind of cities to compare and investigate when you were setting up your study.
Actually, there weren't many previous papers done on gentrification. So these two cities were the ones that were the most reliable sources of previous studies. And using those two cities, I kind of based my study off of that.
Great. All right, Jessica Shu, you're up next.
Okay. Can you see my screen?
Yes.
Okay. Hi everyone, today I will be talking about the impact of electric vehicles or EVs on local air pollution. My goal in conducting this research was to analyze the impact of EVs from a holistic point of view, but focusing on local air pollution. First, I will go into a brief history of EVs, then I will discuss the necessary background, such as emissions data, health effects, and equity, before delving into the data itself. Finally, I will finish it off with limitations and conclusions. The first electric car was invented in the late 1820s and officially debuted in 1890. Moving along, the first hybrid electric car was invented in 1901. For reference, a hybrid electric car is a car that relies on both gas and electricity. Progressing through the late 20th and 21st century, regulations increased and nationwide infrastructure was constantly being improved on. Over the course of the years, legislation has been passed to improve fuel efficiency standards, which are how many miles you can travel per gallon, as well as fuel economy and CO2 standards. I would also like to bring your attention to an important court case in 2006, which is Massachusetts versus the EPA. This court case reinforced the EPA's capability of enforcing these legislations. To start, I would like to go through what the system meaning emissions data, actually measures and what it doesn't. The emissions data that was collected does not take into account recycling at any point of the process, but it includes production, usage, maintenance, and the end-of-life process. In a comparison of 5 regions, this figure found that there is a break-even point in terms of emissions for battery electric vehicles and gas engine vehicles. Battery electric vehicles are only better in terms of emissions after a certain distance due to the major role that battery production plays in total CO2 emissions. Electric vehicles with the least efficient battery production process actually had a higher CO2 emission factor than gas cars, while EVs with the most efficient battery production process had a lower CO2 emission factor than gas cars. This slide goes over the causes of emissions of gas cars and electric vehicles. The primary causes for emissions for internal combustion engine vehicles are production of both the car and the fuel, while the primary causes of
emissions for EVs are the manufacturing of the battery and the emissions that come from rare earth element mining. This is a comparison to show how the cleanliness of the grid can impact emissions for all electric cars. Upstream emissions stem from different electricity sources and can have a major impact on total emissions. As you can see, the EVs and the plug-in hybrids are cleaner in California compared to the average in the United States. That's because California uses a higher percentage of solar power and renewable power to power their grid. Before diving into my studies, I would just like to go over some background info about the pollutants that I will be tracking. VOCs, which are volatile organic compounds, PM2.5, SO2, and NOx are the primary pollutants released from vehicles, and all of them can cause respiratory irritation as well as permanent damage to organs. I would also like to bring your attention to the importance of equity of clean air. I gathered census data about all of the cities within Texas that actually had an automobile manufacturing plant and discovered that 89% of those cities were below the average income in Texas, and 61 of those cities were below the average income by $10,000. Now, why is that important? Cities surrounding automobile manufacturing plants have lower air quality due to the toxic emissions that are released. This predicament unproportionately tends to impact underprivileged communities. Now, to actually get into the data, I chose to compare cities from Texas and California, as California has been one of the front runners in electrifying passenger vehicles, while Texas has not adopted this technology as fast. Additionally, many of the cities in Texas have automobile manufacturing plants. To start, I compared El Paso to San Mateo. Both El Paso and San Mateo carry around 700,000 total cars within city boundaries, which is why I chose to group them together. El Paso is a site of automobile manufacturing and has one of the lowest percentages of EVs within the United States at only 0.31%. San Mateo is a more centrally planned city and has one of the higher percentages of EVs within the United States at 4.2%. As you can see on the figures on the left, the average air quality in El Paso was significantly worse throughout the month of August when compared to San Mateo. Next, I chose to compare Arlington to San Francisco. These cities have around 350 cars total, respectively. Arlington is home to the General Motors manufacturing complex and has one of the lowest percentages of EVs within the United States at only 0.44%. San Francisco, on the other hand, is an extremely urban city and it has one of the highest percentages of EVs within the United States at 11%, despite not needing cars. As you can see on the figures on the left, the average air quality in Arlington was significantly worse throughout the month of August when compared to San Francisco. This is just a visual representation of all the cities' AQI being air quality index. As you can see, the air quality in both cities in Texas is significantly worse, which is most likely attributed to the fact that there are less EVs and the fact that there are automobile manufacturing plants within the cities in Texas. Next, I would like to talk about the limitations of this study. Due to limited data on VOCs and NOx, ozone data was collected instead. This may lead to some inaccuracies as there are other sources of ozone and other pollutants like PM2.5, such as refineries and chemical plants. Additionally, not all VOCs or NOx may be accounted for, as not all of it forms ozone and some of it will act as greenhouse gases within the troposphere. Additionally, depending on the season, the level of ozone will vary as ozone forms through temperature-dependent photochemistry. So ozone forms when NOx and VOCs combine in the presence of intense heat and sunlight. Motor vehicle exhaust and industrial facilities are the major sources of NOx and VOCs. This is why you see a lot of photochemical smog, which is a smog primarily made up of ozone, near LA. The combination of intense sunlight and many cars leads to an increase in ozone. So what is the impact of EVs? A higher EV ratio appears to be linked to better air quality within the community, as indicated by the AQI. It is important to note that there are a multitude of factors that play into AQI that were not taken into consideration, such as weather, temperature, precipitation, and wind patterns. Replacing gas engine vehicles with EVs will lead to less tailpipe emissions, as EVs don't release any tailpipe emissions, which will subsequently improve local air quality. Additionally, less tailpipe emissions will lead to lower levels of ozone, which will increase the capacity to reduce or improve respiratory conditions. So are EVs worth the investment? EVs are better for community health and the health of the earth. They are better in terms of greenhouse gas emissions when in long-term use and local air contamination. However, it is important to consider the cons of EVs as it raises important equity issues. Although it improves quality of life for some, it also has the potential to lower quality of life for others, such as underprivileged communities, especially since the increasing popularity of EVs will lead to more manufacturing plants, which will most likely be located near underserved communities. So what comes next? More expansive legislation needs to be passed to make EVs more accessible, like the Inflation Reduction Act, which was signed into law August 16, 2022. This act provides more subsidies for EVs, which will provide underserved communities the opportunity to purchase them. This act is targeted at eliminating the equity issue revolving around the price of EVs. Additionally, more mandates requiring states to go electric need to be passed. An example of this is the Advanced Clean Cars 2 rule passed by CARB in California on August 25, 2022. This rule requires all new vehicles sold after 2035 to be zero emission. This sets an example for the rest of the country and world to follow. Additionally, we need to keep cleaning the grid. More renewables will decrease upstream emissions, and one day we have the hope to be truly zero emissions. Furthermore, EV technology is rapidly improving. With new technology comes a longer range, better battery efficiency, and lower total emissions. I look forward to seeing the improvements we make within this field. Thank you for listening to my presentation.
Great job, Jessica. And I really love how holistically you approach the topic and all the considerations there. I do have one question. I know you we're talking about kind of like data limitations, right? Or like there's a lot of other factors that could influence this. And so I'm, thinking about, in the future to kind of control for some of these things. Have you thought about like what might be a way to more definitively make those connections without so many competing variables?
I mean, it would be hard unless we like actually made a simulation, but in like the real life world, I think it would be extremely difficult to have a controlled situation as local air pollution comes from so many different factors. Like it would be easier to like measure data near like a freeway per se, but like there's just so many different variables that go into local air pollution, like any emissions from like your house or anything else. So like I think the only way to be like for sure and actually make like a definitive correlation would be actually to create a simulation.
Well, I think that makes a lot of sense. Is that something you're interested in?
Yeah, it is, but like just with the time right now, I did not have the resources or the time. Yeah.
In the future, maybe. Cool.
Yeah.
All right, Abhidi, your turn.
Okay, let me go ahead and
I can see it. All good.
everyone, my name is Abhidi Brahnmath. I'm a freshman, and my Polygens project was a review research paper on the behavioral and neural impact of childhood stressors. Maya was a 10-year-old girl who went through child abuse and was isolated from her peers through bullying. Her parents physically and emotionally abused her. She thought school would be a break from it, but bullies made rumors about her. She sat in every lunch in school alone. Zayden was a 12-year-old boy who lived in a dominantly African-American neighborhood. He was struggling with reading, but his parents neglected him and never tried to help him. Every night, his parents left him alone in the house late with only a pack of cigarettes for him. Maya and Jayden may be theoretical people, but these stories represent real-life situations around the world, not only rewiring our brains, but completely changing the course of our lives. During childhood, one absorbs a variety of experiences that fabricate their perspective, and is understood as a time focusing on internalization and development. It has profound influences on their neuroplasticity, rewiring circuits that they use to think and analyze situations. However, while positive experiences can contribute to the growth of the child's personality, negative, intense stressors can have long-lasting impacts that last into adolescence and adulthood, which is what I wanted to explore in my paper, specifically their neural and behavioral impacts. So today I will first cover the neural impact of childhood stressors as experiences affect the connectivity and function of the brain, and these impacts can influence behavior, and we will discuss how these can further lead to significant behavioral changes. Finally, I will cover what we can do to protect the future potential of our children. The brains of many children who are neglected experience violent behavior, get excited, parents exhibit stance, the child may believe they're insignificant and spiral into more negative learning self-schemas and insecurity. This can lead to psychosis over time. Psychosis is characterized by a loss of touch with reality, and psychotic behaviors can lead to the enlargement of the choroid plexus, which plays a key role in psychosis. Increased size of the choroid plexus can lead to smaller amygdala volume, which you can see in this figure here. This blue spot is the amygdala. And the amygdala is responsible for regulating our emotions and connecting them with memory. Smaller amygdala volume can lead to less emotional intelligence and awareness. Here's another example of how traumatic experiences in childhood can impact brain function. Considering the myriad of stressors that systemic racism brings, oppressed populations may proceed with trepidation when in social situations. This may be why systemic racism is correlated with decreased activation in the ventral medial prefrontal cortex in African American individuals, which is this orange spot here. The VMPPC is found to be responsible for the interconnected aspect of social and emotional cognition and pain management, and decreased activation develops a reluctance to explore the connection between self and society. Decreased activation of the VMPPC is correlated to less activation of the cortical midline networks of the brain, which is also known as the empathy network. We can observe that our brain changes and rewires itself due to stressors in childhood, but what about abnormalities in brain development? Out of the 5 main impacts I looked into my paper, I chose to focus on 3. It has been found that parental neglect is correlated with an abnormality in corpus callosum development in adulthood. The corpus callosum is responsible for connecting the 2 hemispheres of our brain. Without being able to coordinate movement from both sides, it can lead to poor motor coordination, and without being able to call on different areas of the brain to process complex information, the child may fall intellectually behind their peers and have difficulty problem solving, which can lead to cognitive disorders. Additionally, psychosocial neglect, which is an aspect of parental neglect, can adversely impact brain oscillations across many frequencies. Oscillations or brain waves are rhythmic signals indicating how active the brain is. They can significantly impact the person's ability to think in certain cognitive areas, process voluntary movements, sleep soundly, and process episodic memory, which processes specific episodes from the past. Another major point to take away is that child maltreatment is associated with a negative impact on the striatum and medial frontal cortex development, which are critical components of the brain's reward system. This may be because abused children have been thought to believe that rewards are rare and punishment is impending, practically expected. It has been found in previous research that the lateral habenula is responsible for rewarding the wrong stimuli, which leads to flaws in the reward system. An example could be perceiving regret felt from hurting someone as a reward. As parents who mistreat their children often expose them to different degrees of violent stimuli and give them a reward of normal if they do something good, this may result in the victim thinking that their situation is normal and putting their child through the same thing. As many mood disorders and substance abuse arises from abnormal reward systems, this may put the abused child at risk of developing these later in life. So the neural impact of parental, peer, and societal stressors shape the behavioral impacts that affect the course of their lives in adulthood. One of the most prevalent changes in behavior is that child maltreatment is correlated with drug misuse, risky sexual behavior, and criminal behavior in adulthood. Additionally, experiencing sexism is associated with drinking more alcohol. Adults may turn to substances as a coping mechanism for the trauma they've experienced. Their brain may also grow irrational as they may abuse their children, leading to a multi-generational cycle of abuse. Experiencing systemic racism is also associated with the abuse of substances. Undergoing the multitude of conflicts systemic racism brings, oppressed populations often turn to substances for coping. As social stigma grows and Black communities are being overrepresented in media of incarceration over drugs, and they're immediately thought of as guilty, victims may be hesitant to ask for help and thus continue the cycle. This can lead to unfair time away from school and learning, which may be why systemic racism is correlated with less academic achievement in African American males and with their minority compared to students of alternate sex. It has been found in the National Assessment of Educational Progress that over half of Black students are not reading at a professional level compared to 20% of white students. And this is representative of the educational gap between races and can hinder the opportunities Black students get in the future. Systemic racism may also increase college dropout rates due to the multiple remedial classes they may have to take to make up for inadequate learning in previous years, straining their finances and pushing Black students to drop out. Isolated children in social settings also tend to not pursue their educational goals. Peers coming from many talents and educational capabilities, isolated children may not grow up understanding different perspectives and learning from their peers. Not only does this box a child into a flat form of thinking, but they also may never get encouragement from others and feel that they are not talented enough for their goals. Finally, those who experience systemic racism have increasingly been experiencing less quality healthcare, which can lead to a lack of trust with healthcare providers over time. This may act as a catalyst for health disparities and lack of substance abuse treatment because oppressed communities have not developed a relationship with their provider. It is also possible that physicians have implicit bias, which can lead to a box perspective of options for the patient and less awareness about their health when making decisions. Our healthcare system is set in the way that private insurance holders have access to optimal treatments, and those without private insurance typically get mediocre treatment, which may contribute to that lack of trust. Additionally, as sexism spreads, women may feel that they are capable of a narrow range of career choices, frequently describing themselves as stupid at times. Women are often objectified by men, and they may lose self-esteem. Additionally, gender stereotypes of women being primary caretakers may make them feel obligated to stay home, even despite their wishes to pursue higher education. This thought may be sewn into the person's head from childhood. For example, limiting a girl from playing with certain boyish toys may also subconsciously block them from imagining themselves in that field. This may narrow down their career options in life. Now that we have understood the behavioral and neural impacts of parental, peer, and societal stressors in childhood and how they affect them in adolescence and adulthood, we must come together to try to decrease the impact and presence they have in children's lives. Decreasing the number of sexualized women in advertisements and decreasing benevolent sexism in the workplace, such as calling women honey through various consequences, is crucial to maintaining women's productivity and mental health. By investigating underlying policies that contribute to systemic racism and ensuring that they are at the educational standards to pursue further education, we would be able to increase the social connection and opportunities for African Americans. Finally, changed brain structure due to stressors in childhood may be a strong influence on the reason behind criminal behavior, and we must look into how this can sway the outcome of cases. Finally, I wanted to go a little bit into how future studies that we can implement, where we can learn more about the impact of these stressors. A study could be conducted that tests the neural and behavioral effects of socialization in socially isolated children, and the improvement of the brain's reward system could be tracked as well as their motor skill development. We hypothesize that situating a victim of parental abuse in a safer environment will lead to positive growth in the areas of motor skills, socialization, and self-growth. We could also investigate the impacts of benevolent sexism when ingrained in childhood, such as the reiteration of certain pronouns for specific occupation, or the exposure of a limited amount of toys that have a specific occupation connotation. If we integrate solutions like these now, we will be able to decrease the impacts that Maya and Jaden face so that they're able to live their childhood to the fullest, and we can paint kids like them a better future. Thank you so much for your time, and I would like to thank my mentor, Sori Buck. I can take any questions now.
Great job, Abhidi, and thank you for closing out such a great session of all our speakers. I'd love to hear a little bit about, as you were exploring this topic, what was an unexpected thing that you learned as you dove into the literature? What's like one thing that really stood out to you?
I think for me, I was pretty aware of the educational gap that comes with systemic racism, but I think I didn't really realize how, since this is kind of pathological, that this impact that systemic racism has on African American males, females, and children, I just didn't realize the extent it impacts their lives and how it really rewires their brain, and they're able to in a good way and more in a negative way, it really impacts the way that they look at things and how they analyze things. And I think that this overarching concept in society, it was surprising to me how it really impacts people individually. And it was kind of hard.
Yeah, that's something that really stood out to me in it as well as a listener. Maisie, I see your hand. Go ahead.
Yeah, so awesome presentation. So I have a question about, like, do you think that, like, you talk about it before that, let's just say amygdala, like in those like people who are abused, those children who are abused, they might have like a smaller amygdala, like they will have less, meaning that like they will have a lower score on emotional intelligence. So do you think later in life, like, can the amygdala grow bigger if we just like care the child more?
Yeah, definitely. That was actually one of the study ideas that I had proposed. I think definitely integrating the child into more of a social setting. I think because the brain is so plastic, it might be able to, develop those neurons that relate to socialization, and eventually over time, I feel like they would be able to recover the damage that was done, and hopefully we're able to improve those children's lives.
Thank you all so much for such fabulous presentations. It's really impressive, all the work that you all were able to accomplish in your projects, and you should be really proud. I encourage everyone to go check out some other presentations and the rest of today's sessions. Thank you all for your hard work and your dedication to your projects.
Thank you.
Thank
Thank
you.
you.